Machines should adapt to human behavior and not the vice versa. This work tackles this problem on the abstract level of task execution or the cognitive variability. The objectives are to increase task performance and improve human well-being, but the real challenge is the unexpected behavior of the human partner in the collaborative joint assembly task. The solution is to consider the cognitive variability during the design of the robotic architecture and to evaluate the quality of this design experimentally. Our contribution is integrating the HTN technique to manipulate cognitive variability and using human factors to evaluate the quality of the adaptation. The experimental setup consists of a PC, a screen to project the GUI, the UMI Cobot, the pattern, the Lego platform, Lego blocks, and a Raspberry Pi module with a camera. Now we will see three subjects with different characteristics. The first participant, for example, spends more time, gestures, and commits errors while executing the assembly task. The Cobot here assembles 3 blocks, while the participant assembles 7 blocks. The Cobot speed is reduced for the sake of the smoothness of the interaction with the participants. The GUI allows the participant to identify and correct his errors. I will let you see how this participant interacts with the platform. The second participant spends less time than the first one and performs fewer gestures with no errors. The Cobot here assembles 2 blocks, while the participant assembles 8 blocks. You can see how this participant is doing the task with less gestures and less fatigue. The third participant has no errors and consumes less time, but more gestures while performing the task. The Cobot here assembles 1 block, while the participant assembles 9 blocks. This participant is performing the task very fast, as you can see. The variability in performing the task is obvious, and the Cobot was able to detect, explain, and adapt to this variability in a smooth, acceptable way.